Alrighty, so y'all, like I said, this is 6B, and it deals with measures of variation. So y'all, first I'll describe what variation is. So when we're looking at variation, we're looking at how far from the mean or average our data is. So variation shows the relationship between the points of data and the mean. And y'all remember, the mean is the average of all data. So is our data points clumped around the mean, or do we have data points that are spread out across the data? Okay. All right. So the first thing we'll look at is what we call the range. So, y'all, the range is the difference between the highest and the lowest data values. So, the difference between the highest and lowest data values. All right, so to calculate the range will equal my highest value minus my lowest value. Okay, so whatever your highest data point is, you take that and you will subtract your lowest value, and that'll give us the range for our data. Okay. All right. So we're going to look at next what we call the 5-number summary. And then we'll look at how we're going to calculate this. So for the 5-number summary, first we'll have our low value, our lower quartile, and y'all, I'll give you how to find the lower quartile, our median. And y'all remember, median is the middle value, okay? So if it's odd number of data points, it equals that middle number. If it's an even number of data points, then remember we took the two middle numbers, added them together, and then divided that by 2 to get our median. All right, next we got an upper quartile. So low value, lower quartile, median, the upper quartile, and then our high value. So those are the 5 things we look at when we talk about our 5-number summary. So y'all, the low value, that's going to be the lowest data point. All right, then we got this lower quartile. So to find our lower quartile, that's going to divide the lowest fourth of the data set from the upper 3/4 of the data set. So it's like giving you the first 25%. And then from that point to the median would give you the second 25%. Okay. So to find the lower quartile, it's the median of the data values in the lower half of the data set. Okay, so low value is the lowest data point. The lower quartile is the median of the data values in the lower half of the median of the data set. All right, y'all, next we had our median. So y'all, the median is going to be the median of all the data values. All right, then we had our upper quartile. I was going to pull this down a little. So y'all, the upper quartile, it divides the upper quarter from the bottom 3/4. So it's like at the 75%, okay? It's dividing the lower 3/4 from the upper fourth. So it is the median of the data values in the upper half of the data set. So lower quartile was the lower half, upper quartile is the median of the data values in the upper half um, of the data set. All right, y'all. Then the last one was the high value. And y'all, that's just like the low value. If the low value was the lowest data point, the high value is the highest data point. So later on, I'm going to show you how to make what we call a box and whiskers plot using these type of numbers here, okay? The low value, the lower quartile, our median, upper quartile, and high value. And if you notice, this would cover the range because the range would be the difference between the high value and the low value, okay? All right, y'all. So the other thing we're looking at for our variation is what we call standard deviation. And we got another project coming up, and it's going to be dealing with standard deviation. Okay, so I'll explain that in a little bit after we do this. But y'all, the standard deviation is the single number most commonly used to describe variation. So the single number most commonly used to describe variation. So the standard deviation equals the square root. All right, let me let one in real quick. So it's going to be the square root of the sum of the deviations from the mean squared, and y'all, I'll show you how to do this, all over the number of data values minus 1. Okay, so usually what I do is I make me a chart with my data points, and then I find out what they mean by the deviations from the mean. To find that, we take each of the x values and subtract the mean to get them deviations. Then we're going to square them because it says squared. Then we add them all together. That's what they mean by sum. So I'll actually write these steps out for you that I use to find the standard deviation. And then y'all, we'll do some homework problems showing you how to do those. So, steps to finding standard deviation. All right, y'all, the first step, compute the mean. So remember, to compute the mean, I add all the data points and divide by the total number of data points. Okay? And we'll do that in our examples. But remember, the mean is the total data points, is the sum of all data points divided by the number of data points. All right, so that's how we find our average. Add all the data up and then divide by how many we had. Next, I'll find the deviation from the mean for every data point. And to do that, so we're going to find the deviation from the mean for every data point by subtracting the mean from the data value. So y'all, what that means, if your data point is lower than the mean, you're going to get a negative number for that. If your data point is higher, then you'll get a positive number for that, okay? All right, y'all, hang on 1 second. Someone came in. I'm trying to get this row real quick. Okay, we're good. All right, y'all. So let's see. Third step. We find the squares of all the deviations from the mean. So to find the squares of all the deviations, whatever I got when I subtracted the mean, I take those numbers and square them, which means multiply them by themselves. So now, once I find the squares of all the deviations from the means, we're then going to add them together. That's going to give us our sum. All right, y'all. So once I've done this step, I will then divide this sum I got by the total data values minus 1. So right here it says divide by the number of data values minus 1. And y'all, then the last step, once I got this number, I then take the square root of that. So that's the last step, is taking that square root. So the standard deviation is the square root of the quotient. So quotient just means that you did the division, and that'd be from step 4. Okay, so whatever I got when I divided the sum by the total data values minus 1, I'll then take a square root of that number, and that'll give me my standard deviation. So the standard deviation tells us the average deviation of each point from that average, okay? All right, y'all, so I'm going to show y'all how to do standard deviation, and then we'll go play with that homework and stuff. All right, y'all. So probably need calculators on this stuff because we're going to be adding numbers and dividing and all that fun stuff, square roots. So good for calculators on this. So what I'm going to do here is find the standard deviation of the numbers 2, 3, 4, 4, and 6. Just to get you a little idea of how I find my standard deviation. Because y'all, there's a few steps on this, remember. So the first thing I do is I'm going to list all my data points and I'm going to call them X. Okay. So I had a 2, a 3, a 4, a 4, and a 6. So these are my data points. Now remember, the first thing I got to find is the mean or the average of these 5 numbers. So I'm just going to do that on the side real quick. So we knew the mean, we add them all together, and let's see, we got 1, 2, 3, 4, 5 points. So we'll add them all together and divide by 5. So we got 2 plus 3 plus 4 plus 4 plus 6. And y'all, we're going to take that and divide by 5. All righty, y'all. So one of y'all got a calculator. Add these 5 numbers together and then divide that by 5 and see what we get for our mean, which would be the average of these 5 numbers. So any of y'all got a calculator? All right, y'all, let me share my screen to my TI-84. All right, so I'm going to add my numbers first. 2 plus 3 plus 4 plus 4 plus 6 equals 19. And we'll divide that by 5. And 19 divided by 5 gives us 3.8. All right, y'all. So our mean is 3.8. So remember my second step on our list was to find the deviations for each of these points by subtracting this mean. So this column will be x minus our mean. Okay, so we'll take each of these x's and subtract 3.8. All right, y'all. So when you take 2 minus 3.8, you get a negative 1.8. When you take 3 and subtract 3.8, you get a negative 0.8. All right, y'all. When I take 4 and subtract 3.8, I get a positive 0.2. And y'all, since this is the same data point, it's going to give me 0.2. And then finally, 6 minus 3.8 gives me 2.2. All righty, so I got the deviations for each of them. Now, I'm going to take that x minus mean and we're going to square them. So we'll take each of these numbers and multiply times itself. And y'all, what's nice, when you multiply negative times a negative, it'll make it positive. So all these values will be positive when you square those. So y'all, I'll show you how I square those. So if I was doing my calculator and I'm going to square them, I put them in parentheses. So do negative 1.8, close parentheses, and use this x squared button to square it, and then hit enter, and you get 3.24. Then I would do that with the negative 0.08. So parentheses, negative 0.8, close parentheses, and square that, and then hit enter, you get 0.64. So notice all these are coming out positive when you square them, okay? All right, y'all, next we had 0.2. So parentheses, 0.2, close parentheses, square that, and hit enter. We get a 0.04. And y'all, we got 0.02 again, so that's going to give us 0.04. And then finally, we had 2.2. So I'm going to put that in parentheses, close parentheses, square that, and hit enter. And I get 4.84. All right, y'all, so I have my x's. I found my deviations by taking each x and subtracting my mean of 3.8. Then I took each of these deviations and squared them to get these numbers. Now, since all these numbers are in a column, we're going to add them together. That's going to give us the sum of all these deviations. Right? So that finishes that step 3. We found the deviations and squared them. Now we're going to add them together. And y'all, when I added all these together, that gave me 8.8. All right, so remember my formula was the square root of the sum of the deviations from the mean and that was squared divided by the total points minus 1. Well, y'all, we got the top done because we got the sum now. So, what we need to do next is take that sum and divide by the total points minus 1. And then we'll take the square root of that. So that's going to equal the square root of this 8.8. All right, let's see how many points we had. We had 1, 2, 3, 4, 5 points. So the total points minus 1 would be 5 minus 1. So y'all, that'll give me square root of 8.8 divided by 4. So you can punch all that in at once, or you can do this part. You can do the 8.8 divided by 4 and then take the square root of that. Either way it'll work. Since I use a TI-84, let me show you how to do it all in one step. So I'm going to share that calculator. I'm going to clear everything off. So the first thing I'm going to do is hit the square root by hitting second x squared. And y'all, if you want it to look like a fraction, you can hit the green alpha button, y equals, and enter. And it'll put it in just like a fraction. And you can do 8.8 on top, arrow down, and put your 4. So notice you can do it that way and get an answer. Now let me see. They round these to the nearest hundredth. So the nearest hundredth would be where the 8 is. So y'all, since that's a 3 after the 8, I would keep that at 8 and make that 1.48. So what that means is, since my mean is 3.8, most of my data points are within 1.48 units of that left and right. And y'all, this is what we want. How far from the mean are my averages, okay? All right, y'all, so standard deviation is fun. So y'all have a project coming up. So y'all will have to do this eventually, okay? All right, y'all got any questions yet? Because I want to show y'all how to do some of these homework problems. All right, y'all, so let me share that homework page with you. All right, y'all, the very first thing I told y'all was how to find the range. So A says the range of a data divides the lowest 3/4 from the upper fourth. Well, no, y'all, that's the upper quartile. The range is the difference between its medium and most extreme value. No, we didn't say nothing about that. The range of a data set divides the lowest fourth of the data from the upper 3/4. No, that's the lower quartile. So y'all, there's only one that's going to make sense. And the range of a data set is the difference between its highest and lowest values. So y'all, for that one, we definitely want to go with D, since we said the range equaled the highest point minus the lowest point, okay? All right, y'all. So A, B, C, or D, I gave y'all how we find the 5-number summary will go. So was it the low value, variance, median, standard deviation, high value? Was it the lower value, lower quartile, median, upper quartile, high value? Was it the low value, lower quartile, mean, upper quartile, high value? Or the low value, variance, mean, standard deviation, and high value? Well, two of them are exactly alike, other than one's using median and one's using mean. But remember, when we gave out the 5, we said the median is what we used to find all these, okay? Remember, the lower quartile was the median on the lower half, upper quartile was the median of the upper half, and then we went with the median of all the data in the center. So, y'all, that would definitely be B. All right, so it looks like I'm going to show y'all how to do a box plot real quick. So let me find my example so that y'all can see how to do that. And really what a box plot is it'll show the 5-number summary visually. So I'm going to show y'all real quick how to find that. So using a box plot. All right, y'all. So let me see. I'm going to use data. So there's a bank, and they was looking at wait times. And for this big bank here, they found the low value for waiting time was 4.1 minutes. The lower quartile they got was 5.6. So remember, the lower quartile was the median of the lower half. Their median was 7.2. So that was the middle of all the data. The upper quartile was 8.5. So remember, that's the median of the upper half of data. And then the high value. So the longest someone had to wait was 11.0 minutes. So the shortest amount of time someone waited was 4.1 minutes. The highest value was 11. And the middle or the median was 7.2. All right, so for a box plot, here's what you do. We're going to draw a box. Your median is in the box here. So what was our median? 7.2. So if we had a scale for data, let's say my smallest value is 4.1. So I'll start about 4.0 here. 4.0 here. 4.1 here. 4.2 here. 4.3 here. 4.4 here. 4.5 here. 4.6 here. 4.7 here. 4.8 here. 4.9 here. 4.10 here. 4.11 here. 4.12 here. 4.13 here. 4.14 here. 4.15 here. 4.16 here. 4.17 here. 4.18 here. 4.19 here. 4.20 here. 4.21 here. 4.22 here. 4.23 here. 4.24 here. 4.25 here. 4.26 here. 4.27 here. 4.28 here. 4.29 here. 4.30 here. 4.31 here. 4.32 here. 4.33 here. 4.34 here. 4.35 here. 4.36 here. 4.37 here. 4.38 here. 4.39 here. 4.40 here. 4.41 here. 4.42 here. 4.43 here. 4.44 here. 4.45 here. 4.46 here. 4.47 here. 4.48 here. 4.49 here. 4.50 here. 4.51 here. 4 And let's see, we'll make 5, 6, 7. Oh, y'all, let me start over. I got to go all the way to 11 on this, right? All right, so here we go. Let me pull this down. I want y'all to see this. So let me make my scale first. So 3, 4, 5, 6, 7, 8, 9, 10, 11. I'll go all the way to 12 since my highest value was 11. All right, so right here, this left side of the box is going to represent your lower quartile, which was 5.6. So I'm going to estimate that 5.6 is right around here. All right, then I'm going to take my upper quartile, which was 8.5. That's going to be this line right here. So let me find 8.5, and this line will be my upper quartile. Now I'm going to make this into a box. So lower quartile, upper quartile. Our median was 7.2. So y'all hear 7. So 0.2 is just a little past it. So this is my median. My lower quartile, and my upper quartile. So this is the box part. So the whiskers, we're going to draw whiskers off of this. They go from the low value of 4.1. So y'all, here's 4. So I'm going to come up, make a little line about 4.1, and then that hooks to my box. My high value was 11. So over here at 11, I'm going to draw another whisker, and then I'm going to draw this all the way across to that other whisker. So now this is a visualization because this is my low value and this is my high value. My median, lower quartile, upper quartile, my low value, and my high value. So knowing what I did here, you will be able to answer this next question we had. So we drew a number line that spans all the values of the data set, enclosed the values from the lower to upper in a box. So that's what I did. But then it says, draw a vertical line through the box at the mean. Number 2 says, draw a number line that does all the values. Enclose the upper and lower. But now look here, draw a vertical line at the median. That's exactly what we did. And then we added the whiskers from the low and high values. So y'all on that one, you want to go with B. Y'all watch out. They throw mean in there. Mean is the average, but on these, we're looking at the medians of these numbers, okay? And then it looks like the last one, they're doing the mean again. So these are the steps to drawing our box plot. All right, y'all, let's see what's next. So look here, this is sort of the process we was using to find the standard deviation. Oh, y'all, that's the same numbers I used, 2, 3, 4, 4, and 6 a while ago. So it just wants the steps I did to figure out that standard deviation. So compute the mean of the data set was our first step. Then we found the deviation from the mean for every data value by subtracting the mean from the data value. That was the x minus mean column. All right, once I did that, we found the squares of all those numbers. Remember, that was my x minus mean squared column. So we squared them all. And then we added them all together once we squared them. All right, we divided this sum by the total number of data values, total number of data values minus 2, or the total number of values minus 1. So y'all, what would y'all pick on that one? The total data values, the data values minus 2, or the data values minus 1. And y'all, guess what? We did the total data values minus 1. And y'all, the last step was the standard deviation is the square root of that quotient. So y'all, it's just like the 5 steps we had a while ago. All right, y'all, so we did this a while ago. So, oh, they want me to round it 3 decimal places. So let me see. Let me go back and look at what I had. So I rounded it to 1.48. It had a 3 after it, so that would be 1.483. So y'all think about this. If all these data values were the same, so let's see what would happen. So let me go back to my paper and show you what they're asking on that. So they're saying, what if all these data values were the same? So they're saying I had 5 data points. So what if they were all 4? So let's see what would happen if all your data points were 4. When you added that together, 4, 8, 12, 16, 20, you would get 20 divided by 5, which means our mean would be 4. So here's your points. Here's our x minus mean. Y'all, what's happening here? You got 4 minus the mean of 4. So 4 minus 4, that's going to give you 0. 4 minus 4, 0. So you're going to get 0 on your deviations. So y'all, if you're getting 0 on your deviations, that means that if every data point was the same, the standard deviation would be 0. Because when you square 0, you still get 0. When you add all them zeros together, you still get 0, okay? All right, y'all, they just want to know if this makes sense or does not make sense. Both exams had the same range, so they must have had the same median. Well, that don't necessarily have to be true. Think about it. If you had, say, a range from 70 to 100, that's a range of 30, between 70 and 100. But y'all, what if your high and low on another test was 50 to 80? That's still a 30 range, but they're not going to have the same median. Okay? So they must have had the same median. That don't make sense. So that range would be the difference between the highest and lowest values. And remember, it has nothing to do with the median. You can get 30 between 70 and 100. You can get 30 between 50 and 80. Okay, so it has nothing to do with that median. Let's see what they want to, does this make sense or not? Let's see. The standard deviation for the heights of a group of 5-year-old children is smaller than the standard deviation for the heights of a group of children who range from 3 to 15. Well, y'all, I would think you would have more deviation in the 3 to 15, right? You're going to have little kids and you're going to have teenagers. A lot of difference in height. To where the 5-year-old children should be really, really close in height. Some might be a little taller, some might be a little shorter, but you're going to have smaller deviation in the 5-year-olds than you would in the older group, okay? So, y'all, that should be true, right? Let's see, the statement makes sense. All right, Jasmine, that's all right. Because the range of data for the heights of 5-year-olds is smaller than the range of data for the heights of children who range from 3 to 15. So y'all would think you would have a lot greater range on the 3 to 15 than you would on them 5-year-olds, okay? All right, y'all, so let's see. After recording the pizza delivery times for 2 different pizza shops, you conclude that one pizza shop has a mean delivery time of 44 minutes with a standard deviation of 3. So what that means, the average of all of them was 44 minutes. Standard deviation of 3 minutes means on average they're coming in between 41 minutes, which is 44 minus 3, and 47 minutes, which is 44 plus 3. So in between 41 and 47 minutes. All right, the other shop had a mean delivery time of 42 minutes with a standard deviation of 18. So that means they averaged 42 minutes. Some people got it 18 minutes earlier than that, which would be, 24 minutes? But y'all, some people waited an hour, right? 42 is the average, but that's a large standard deviation. So if you like the pizza from both shops equally well, which one would you order from and why? All right, so the variations are nearly equal, but the mean is greater for the first shop. No. The means are nearly equal, right? 42 and 44, but the variation is significantly lower for the second shop. Well, no, y'all, the second shop had 18-minute variation. So let's see, the means are nearly equal, but the variation is significantly greater. So although it averaged 42 minutes, you might not get it for an hour, right? So that's when we want to pick on that because 18 is greater than that 3-minute deviation. And y'all, that's what you got to look at overall. I mean, more than likely the other shop might be quicker, but you never know because they got such variation. So it says if you like pizza from both shops, which would you order from? Well, the second shop, 42 minutes with 18, that's pretty big. And see, you would choose that first shop because it has a more reliable, because it has a lower standard deviation. No matter what, you're going to be averaging about 41 to 47 minutes on that one, okay? So that's what you're mainly looking at is that standard deviation on those. All right, so a report claims that the returns for the investment portfolios with a single stock have a standard deviation of 0.57, while the returns for portfolios with 31 stocks have a standard deviation of 3.27. So explain how the standard deviation measures the risk in these two types of portfolios. All right, y'all. So read those and see what y'all think. All right, so what y'all going with? A, B, C, D, or E? All right, y'all. So it looks like the standard deviation of 0.327 is lower than a standard deviation of 0.57. So there's less variation. So lower variation would mean less risk. So let's see. So y'all, that looks like D, right? So remember, you're looking at how high to how low those variations are on those. All right. So each night you total today's sales and the total volume of ice cream sold in your shop. You notice when bin works, the average price of the ice cream is $2.90 per pint with a standard deviation of 40 cents. On nights when Jerry works, the mean price of the ice cream sold is $2.95 with a standard deviation of 0.05 cents. So which employee likely receives more complaints that his servings are too small? Well, y'all, Jerry works, he only had a standard deviation of 0.05. Ben works, his standard deviation is real high at 40 cents. So that means sometimes he's giving people 250 worth of ice cream versus the 290 for the full pint. So we're going to say Jerry got less complaints. That means Ben got more complaints. So let's see, because the means are pretty close, 290, 295. Um, but see, that's wrong because his standard deviation is smaller. He's serving more small portions. Uh, Ben, let's see. So which one was Ben? Ben was the first one. He had 40% higher deviation, which is higher. So he more than likely served more small portions, okay? So remember, look at that variation and that standard deviation and sort of compare those. All righty. I'm going to save this one for Thursday night for us. Um, that way y'all can sort of study this and figure it out. Because what we're going to do Thursday when we start, we're going to come in and do all this question. We're going to find its standard deviation. We're going to make box plots and everything on this question, okay? So I just want y'all to get familiar with this material a little more. That's why I made this the only assignment for this week. And what I want to show y'all real quick is a little information on your next project. This will be your statistics project. So y'all, what we're going to be doing is finding means and standard deviation and all that fun stuff. So your task, and let's say by next Tuesday, y'all have some kind of topic y'all want to research. So I need y'all to poll. So you're going to take a poll of 10 to 20 people. Okay, so social media, y'all shouldn't have no issue finding 10 or 20 people to ask them a question. So an example question that I did when I was in school, since I was a student, I took a poll of 20 students. So for me, I took a poll of 20 students and I asked them, how many hours do you study per week? So I had 20 people and I asked them how long did they study per week. Some gave me answers like 10, 12, or higher. Some didn't study very much. But y'all, I just need y'all to find 20 people and give yourself about a week. Um, and I'll sort of help you to see if it's a good question or not to ask. Um, you can ask people, how much did you pay for your shoes? How much did you pay for your phone? Anywhere where you can get data. How much do you spend on groceries a week? Okay. So find 10 to 20 people that you can ask them a question and you're going to get your data. And from there, I'll show you what we're going to do next. Okay. So try to do this part. So try to do this by next Tuesday. Okay, so this will be our last project for the class. And it's a little more involved than that first project we did. And this would be the first step, y'all. You can ask people on Facebook, Snapgram, or any of those, and try to get you some data. Or you can ask people face to face. It does not matter how you get your data, but I need y'all to get some data between 10 and 20 people, okay? All right, y'all, any questions?